Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which I'll go through the volume and capacity of prisms. So firstly, we need to know what a prism actually is. So prisms are 3D shape with a consistent cross-section. So the first shape here is a prism. It's a triangular prism. So if I, were to cut it here, what I get here is the same shape, same triangle, and same size as the base here, the triangle. That's what I mean by consistent cross-section. That triangle is the cross-section. So the second shape, whether you call it a cube or whether it's a rectangular prism, a cube is a special type of rectangular prism, so this has a consistent cross-section. If I were to cut it parallel to the base here, I'm going to get myself a rectangle that is going to be the same size as the top. So this here is going to be a rectangle, same as the top, if I cut it there, okay? Third shape, a cylinder. Well, that's actually a type of prism as well. Well, pretty much type of prism. It has a consistent cross-section. If I were to cut it parallel to the base, I'd get another circle that's the same size and shape as the one on top. So these first three shapes are all prisms. So we have a cylinder here, a rectangular prism or cube, and a triangular prism. They're sort of the main types of shapes we'll be looking for. They're all prisms, so in this video I'm going to show you how to find their volume and capacity. The fourth shape here, the last shape, is not. It doesn't have a consistent cross-section. You can see that the top is a point, whereas the bottom is like a rectangle. So that shape is not a prism. Pyramids are not prisms. So we're not looking at those types of shapes. What we're looking are prisms. So the way you find the volume of any prism is actually pretty simple. The volume is just A times H. So A is the area of the cross-section, or if you like, the area of the base, but the base isn't always on the bottom of the shape. So of course, in this shape here, we're talking the cross-section is a triangle. So the volume of that shape will be the area of the triangle times by H, which is the perpendicular height. It always means perpendicular height, never slant height. So here the cross-section was a rectangle, so the area of that rectangle times the perpendicular height will give you its volume. In the cylinder, you find the area of the circle at the top and the bottom, that's the cross-section, and then you times by perpendicular height. But that won't work for pyramids. You'll probably learn that in a few years' time. So let's look at some examples of actually calculating the volume of a shape. So let's find the volume of this prism here. It's a triangular prism. Sorry about my bad drawings. So the area of the base, the cross-section, which is the triangle, is base times perpendicular height divided by 2. So that part here is the A. You don't actually need to put brackets in your calculator. I'm just showing you which is which. And then I'm going to times by 15, which is the H, which is the height. So you just put that on your calculator. 11 times 9 divided by 2. Get your answer and times by 15. And you should get 742.5. And the answer is centimeters cubed this time. So we're looking at cubic units. So that is the volume. So what about capacity? What does that mean? Well, capacity and volume are essentially the same thing, just in different units. So volume is cubic units. We're talking about millimeters cubed, centimeters cubed, meters cubed, and the like. Capacity, we're talking about liquid measurements like milliliters, liters that you would be familiar with already. So the conversion is that 1 centimeter cubed equals a milliliter. That's the definition of a milliliter. So if I made a container in the shape of this triangular prism with these dimensions, it could hold 742.5 centimeters cubed, or 742.5 milliliters. Another conversion you need to know, you probably already know, is 1 liter is 1,000 milliliters. So this shape holds 742.5 milliliters. I just divide by 1,000 to get it in liters. It's 0.7425 liters. Okay, sometimes the question might say, how many milliliters can it hold? How many liters can it hold? All right, let's now look at another example of finding the volume of a prism. So let's now find the volume of this cylinder here. Its diameter is 20 meters and its height is 30 meters. So the volume is just the area of the cross section times the height. So the area of the cross section is the area of the circle, pi times, so not 20 squared, the radius is 10 because the diameter is 20. So that's my A, area of the cross section. I now times that by the perpendicular height, 30. If I put that on my calculator to the nearest whole number, I should get 9425. So the answer on my calculator was 9424.777. Because the first number after the decimal point was 7, 5 or more raised the score. So it's 9425, and we're in meters cubed. So I now want to figure out how many liters this would hold. Let's say it was like a water tank. How many liters of water would this water tank hold? So I need to know a bit about conversions. So we've sort of seen this chart before. Remember when you wanted to go from millimeters to centimeters, you divide by 10. The other way, you times by 10, and there are 100 centimeters in a meter. Remember, of course, the rule was that when you're going from a smaller measurement to a larger measurement, you divide, and if you're going from a larger measurement to a smaller measurement, you times. So remember, for like millimeters squared to centimeters squared to meters squared and kilometers squared, you had to square the conversion factor. Here we cube it. All of these now need a cube. So for example, to go from millimeters cubed to centimeters cubed, you need to divide by 1,000. There are actually 1,000 millimeters cubed in a centimeter cubed, and so on. Right? So how's that gonna help us? Well, we know that 1 centimeter cubed is a milliliter. So I want to put this answer here into centimeters cubed. So I'm going to follow this arrow here. So what I have, meters cubed to centimeters cubed, I times by 100 cubed. Now 100 cubed is a million. So believe it or not, 9,425 meters cubed is the same as 9,425 million, or 9,425,000,000 centimeters cubed. It's a lot when you think about it. There are 1 million centimeters cubed, or 1 million milliliters in a meter cubed. So this answer here is 9,425,000,000 milliliters. So I can divide by 1,000 to get liters, because remember, 1 centimeter cubed is a milliliter, and then there are 1,000 milliliters in a liter. So this tank would hold 9,425,000, 9,425,000 liters. So we have other measurements for when you've got heaps of liters. So I have a measurement called kiloliters, which means 1,000 liters. So if I divide this by 1,000 again, I can write it like this: 9,425 kiloliters. A kiloliter is 1,000 liters. So if I made a water tank in the shape of a cylinder with these dimensions, it would hold 9,425 kiloliters, which is 9.425 million liters, which is 9,425,000,000 milliliters. So that's how you convert capacity and volume. It's usually easiest to convert the number into centimeters cubed, which is milliliters. They're the same thing, and then convert to liters. Another fact you might like to know is that 1 meter cubed equals 1 1,000 liters, okay? It's just that it can be hard to remember all these conversions, so as I said, it might just be easier for you to convert your answer into milliliters, i.e. centimeters cubed, and then convert to liters. All right, sorry for the long video. This has been the luckiest maths teacher in the world. Have a great day.